Okay, so we are going to consider glass slab and we are going to deal or derive what is happening when a light is being passed through the glass slab. Okay, so this is nothing but a glass slab whichever we have it in our hand. Okay, so when the light is going to pass, obviously what will happen? So when the light is going to pass through this, can you see this? Yes, so the light is going to bend, correct? So but கீழ அதே மாதிரி என்ன ஆகும், இந்த லைட் ரே இங்க பாஸ் ஆயிட்டு it is going to bend somewhat and it is going to refract like this. Okay, but can you see the difference here? The light ray which is going to pass through this is going to be parallel to the light ray which is incident. நல்லா பாருங்க, after refraction the light is going to come. Okay, and before that, okay va, so partial reflection and partial refraction நடக்கும், but since we are only handling refraction now, just concentrate on that. So இப்போ வந்து நம்ம இப்படி ரிஃப்ராக்ட் பண்ணிட்டு இருக்கோம் அப்படின்னா அங்கே பார்த்தீங்கன்னா you can see the light is going to bend and move. தெரியுதா? என் கை எங்கே இருக்குது, அந்த லைட்டோட லைக் பொசிஷன் எங்கே இருக்குது பாருங்கள், ஆஃப்டர் ரிஃப்ராக்ஷன். ஓகே, ஜஸ்ட் இஃப் ஐ எம் டேக்கிங் திஸ், யூ கேன் see the light is again parallel only, right? அட்லீஸ்ட் அது சேஞ்ச் ஆகுது பொசிஷன் இங்கே. ஸோ யூ கேன் see this. ஸோ இங்கே தெரியுதா, கொஞ்சம் லைட் வந்து கொஞ்சம் லைட்டாக ஷிஃப்ட் ஆகும். எஸ், எடுத்தனா அங்கே போதா, இப்போ இங்கே வச்சனா இங்கே வருது பாருங்கள். ஸோ கொஞ்சம் லைட்டாக பெண்ட் ஆகுது. ஓகே, பட் நவ் வாட் இஸ் த கேஸ் இஸ் how far it is going to be varied with respect to angle, incident ray and the emergent ray. Consider a glass slab. Okay, so what I'm going to do is I'm going to just draw the reference lines first. So this is going to be normal. Okay, I'm just going to incident a light ray with an angle of incidence I. Okay, let me take this as A and this as B, and the rectangular glass slab have points P, Q, R, S. Okay, so AB is going to be the incident ray. Okay, now what will happen? There will be bending of light because the light is going to travel from rarer to denser. So this is going to be the angle of refraction. Okay, right? And then see this. This is the rear part, parallel part of PQ. Okay, now what will happen to the light here? This is going to be the incident ray of this particular surface. Okay, say I take this as I1, R1, I take this as I2, and it is going to bend away from the normal because it is going to travel from denser to rarer. Okay, so if that is the case, this is going to be what? R2. Yes, clear with this? Okay, so this is called as incident ray, this is called as refracted ray, and this is called as emergent ray. What is emergent ray? What is the difference between refracted ray and the emergent ray? See, refracted ray can again undergo refraction, but an emergent ray is going to be the final ray which is going to come out of after refractions. Okay, right? No possibility for refraction again. So those type of rays after multiple refractions or refractions which is coming out is called as emergent ray. Is that clear? Right? Yes? Okay, so we have this. Now let me name this again. So let this be C and let this be D. Okay, right? And the normal N, okay, this is going to be N dash, and this is going to be N dash N, right? Okay, so now first we will consider this first condition. Say this is first, second and 1 again. Okay, so when you are considering this, what will be the Snell's law conditions? Okay, that is what we are going to deal with. So let us consider this PQ surface first. Okay, so idhula vandu angle of incidence to that of angle of refraction is equal to Snell's law, that is what is constant. Okay, so what you'll get, sin I1 to that of sin R1 is equal to refractive index of second medium with respect to first medium. Okay, so this is when you consider this particular surfaces. Okay, right? So when you take this as angle ABN, angle N dash BC, right? So sin I1 to that of sin R1 is equal to mu12. Coming to the next part, right? So let me consider this as first equation, and coming to the second part, what you will get here, this is now going to be angle of incidence, this is going to be the angle of refraction now, correct? So what you'll get, so when you are taking this particular angles, yeah, n dash cb and angles ncd, right? So if this is the case, then what you'll get here, sine I2 divided by sine R2 is equal to mu 21, correct? So this is going to be second equation. Now what you'll do, multiply 1 and 2. If you are doing so, what you'll get, sine I1 by sine R1 into sine I2 divided by sine R2 will be equal to mu 21 into mu 12. Now we know pretty well this angle and this angle are going to be same. Why? Because PQ and RS are parallel. Okay, so since PQ is parallel to RS, angle R1 will be equal to angle I2, correct? So when you are replacing it, what you'll get, sine I1 divided by sine R1 into sine R1 divided by sine R2, right? So which is nothing but mu 12 into mu 21. Cancel. And also you have already seen that if you have the same medium, there is possibility for reciprocality, right? So what will they do then? So mu 12 can be replaced as mu 21, reciprocal of. So replacing that, what you'll get, so 1 mu 2 into 1 by, so you'll get cancelled each other. So what you'll get now, sine I1 by sine R2 is equal to 1. Sine I1 is equal to sine R2, which is nothing but I1 is equal to R2. So what it means, the angle of incidence is equal to angle of emergence, right? So angle of incidence is equal to angle of emergence. So according to parallel glass slab, or according to glass slab, when you have two parallel surfaces, okay, the incident ray and the emergent ray will always have the same angle with respect to the normal, which means what, angle of incidence is equal to angle of emergence. Okay, so this is what is the proof for that. Is that clear? Right? So refraction through a glass slab. Okay, any doubts? Are you clear?